Okay, guys. Good morning, guys and gals, and whatever. Today we're solving problem 2358, maximum number of groups entering a competition. 2358, 2 plus 3 is 5, and 5 plus 3 is 8. Just a strange coincidence. Little numerology for you. All right, but that's unrelated to this problem. Only a coincidental fact. Okay, you are given a positive integer array grades, okay, which represents the grades of students at your university. My grade would be 100. You would like to enter all those students in a competition ordered non-empty groups such that the ordering meets the following conditions. Okay, so I'm giving these students, I got all these students' grades. I'm like, okay, this guy's good, this guy's bad, this guy's smart, this guy's dumb, blah, 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 blah. And the sum of blase, as the kids say, the sum of the grades of students in the ith group needs to be less than the sum of the grades in the students in the ith plus 1 group. Okay, so I'm going to create groups like, I don't know, G1 and G2 and G3 and so on and so forth. Okay, now the sum, all right, I'm going to use some mathematical notation here just to prove to you that all these degrees on the wall aren't completely useless. The sum of, G of I has to be less than the sum of the next group. The less than the sum of G of I plus 1. Okay, so we're going to make groups where, I have groups in an order, and I say, okay, this first group, their grades in totality are less than the totality of the groups ahead. All right, so that's my first condition. And my second condition is that the total number of students in the ith group is less than the total number of students in the next group. Okay, so I'm going to use this to mean the magnitude. So this is the length, right? So the number of students in G of I needs to be less than the number of students in G of I plus 1. And this just means, sum. So it means if I sum all the elements in this group and I take the length of this group, it has to be less than. Okay, so these are pretty strong conditions. And these strong conditions are really going to contribute to how simple this problem actually becomes. But it may not be completely clear now. But as we kind of walk through solutions that pass, we can kind of break the solution down and realize, okay, well, really that just means this, which is much simpler and faster to compute. Or really that just means this, which is much simpler and faster to compute. And that'll make sense in a second, okay? So with these two constraints, we want to return the maximum number of groups that can be created, that can be formed. Okay, so let's look at this example problem then. So for example, we have grades equals 10. We'll zoom in here a little bit. No, I don't want to zoom in because I want to keep this all on one beautiful page, okay? Grades equals 10, 6, 12, 7, 3, 5. 12, 7, 3, 5. All right. And look at this. It's like I could point at it. So this is super unintuitive because that's not where it is. You see this over here? That looks good. And if we look up there, that stuff looks good. Oh, wouldn't it be cool if I could make some software where I could point out? Maybe that's something I should work on. Grades 10, 6, 12, 7, 3, 5. Okay. And the output is 3. So we can make 3 groups. Well, how would those groups work? Well, each group needs to be smaller than the next group, the subsequent group. And each group needs to have a sum that's smaller than the subsequent group. Subsequent meaning the next group, right? So how are we going to end up doing this? Well, turns out that you could have the first group with the person of 12. Okay. So this would be your G1. You could have your G2 be 6 and 7. It's funny. So one thing to note, right, is that we'll talk about that in a second. 12, 6, 7. 10, 3, 5. And that's it. Right. So with that, we were able to get, okay, this is confusing because it makes it look like it's 1, 2. So what? 12. All right. So 12, 6, 7, 10, 3, 5. And with that, we get 3 groups, right? So that's where we return 3. Are these conditions met? Well, yes, the sum of this one is 12. The sum of this one is 13. So that's less than The number of elements in this one is 1. The number of elements in the subsequent one is 2, so it's less than. This one, the sum is 13. The sum of the next one is 13 plus 5, 18. So yes, that's met. The number of elements in here are 2, and the number of elements in the next one are 3. Right, so it meets. So all the conditions are met, and this can be shown to be the ideal solution. Okay. So what's funny about this is they're intentionally, sometimes the solution is so simple that if they reveal the idealized way of solving the problem in the example, it'll reveal too much. So sometimes they'll do like alternative answers, because sometimes there's more than one answer that meets the conditions, right? Sometimes there's more than one situation that'll result in the thing that you're looking for, right? So sometimes they'll give you an answer that's not the ideal way of doing it, meaning ideal in terms of like the most easy to calculate way of doing it. If that, what I know makes sense, all I'm basically saying is sometimes examples intentionally screw you over. Sometimes examples intentionally do the wrong thing to confuse you or to not reveal too much about what the answer would look like, okay? But one thing to think about here is, well, you know, every group, let's think about this condition alone, right? Every group needs to be less than the length of the next group, okay? So in order to maximize the number of groups I should make, well, I'm trying to make as many groups as possible, right? So since I'm trying to make as many groups as possible, I'm going to want to, you know, not overuse people, right? Because if I choose my first group to be one person, or no, let's say if I choose the first group to be 2 people, well, then what does that mean about my next group? My next group is going to have to be 3 people, right? And the next group would have to be at least 4 people. So if I'm trying to make as many groups as possible, I should instead always try to make my first group 1. That way my next group could be 2. And that way my next group could be 3. So the greedy approach here is, well, since every group has to be larger than the one before it, okay, and I'm trying to maximize the number of groups that I make, I should make my first group as small as possible so then the subsequent one could be as small as possible and small as possible, right? Because I'm trying to maximize the spread, right? If I'm trying to make, I don't know, it's just like this, right? If I'm trying to distribute people in groups such as I have as many groups as possible, then I should split people out as much as possible, right? What if there was no constraints and I was trying to maximize the groups? Well, that would mean I'd put everyone in their own group, right? So we had all these people and there were no rules. And they says, I'm trying to maximize the number of groups. And then someone introduced this rule and say, okay, well, every group needs to be smaller than the subsequent group. But it's like, okay, well, then I'm still going to leave this guy alone. And maybe I'll put this guy over here. Okay, and then this guy has to be bigger. Right, so maximizing the groups can happen when you're given this constraint by making the first group as small as possible. You know, you're trying to make the groups as small as possible to maximize the number of groups that you have, right? The more people you have, okay, the smaller the group size, the more groups you can make, right? It's like you take a pie and you're trying to maximize the number of pieces that you get out of it, the number of groups, the slices you get out of the pie. You're going to try to make the pie slices as small as possible. The same thing's true here, right? So you should always make the first group size 1. Unless you can't here because, you know, you'd have 2 groups of size 1. But here, right, the idea is make the first group size 1, the next one size 2, the next one size 3, and keep going on like that, right? That way you can maximize the number of groups that you can make, okay? So that's kind of the point to address here, right? Always first group size 1, second group two, 3, etc. That's kind of how it was, right? The group size 1, the group size 2, so on and so forth. Okay? But what you might be saying is, well, how do you know if you make a group size 1 that the next group, even though it might have 2 elements, that it's larger than that group? Right? Like, what if you had, for example, a situation like this? You know, you had 15, 1, 1. You might say, okay, I'll put 15 in group 1. And these 2 in this group like this. For example, now this second condition is met, right? but the first condition is not, right? Because the sum of this group is 15, the sum of this group is 2. Obviously, that doesn't work. Okay. But, you know, the maximum number of groups you can make for anything follows this pattern, right? But this pattern doesn't always meet condition 1 in all situations, right? If you had 5 elements like 15, 1, 1, 2, 3, 4, right? 2, 3, 4, 2, 2, 3, whatever, it doesn't really matter. 1, 1, 2, 2, 3, like this, right? When you're given that initially in an array, it would look like this: 1, 1, 2, 2, 3. Right? You might say, okay, I'll split them up in groups to maximize the number of groups that I can make. But so this would be the maximum orientation, but it doesn't meet the first condition. But the thing that doesn't really matter is, well, it can always meet the first condition just by putting the smallest ones first, right? So I can always make this condition true given this constraint if I just put the smallest ones first. So if I instead sort this array and then paint it like this and paint it over 1, 1, 2, 2, 2. Guys, I'm like so dumb. It's like crazy. 1, 1, 2, 2, 2, 3. Let's say there was no 15 here. Whatever. It doesn't. Well, now it's already sorted then. Let's say this was 2. This 3 doesn't exist. Okay. Really bad video today. Like always. So this 3 doesn't exist. This would be 15. You'll notice that this meets the condition. Why? Because, okay, we've split them up to make as many pieces as possible, right? We took the pie, given the constraints, and we made as many pieces as possible where each piece is slightly bigger than the last piece, right? And we realized that, well, the value of that group might be larger, but, you know, it doesn't really matter the orientation here because we can just switch it around and paint it such that we paint the groups like this: 1, 2, 2, 2, 5. Okay? So what we could do is we could take, for our code, is we could take our array. Our array here is grades. So our solution could be, I'm losing it. We could take grades, we could sort it. Then we could figure out how many groups we can make, right? So we could say group size equals 1. And we could say, while there's people in the group, so while there's still grades available, so let's say the length of grades is greater than 0, we'd say, okay, grades minus equal group. All right. And then we'd say, okay, now we have another group of a larger size. And then we return the number of groups that we were able to make. Right, so you have a group of size 1. You remove that. You might need to do G minus 1 here. Something like that. But it doesn't matter because we're going to keep iterating this code and fixing it. But basically what I'm saying is, like, I have my group here. So basically what this code does, using... let's use the example provided. So 10, with the example 10, 6, 12, 7, 3, 5, right? What this does is when we walk through it, we're going to say, while grade's greater than 0, so we sort the system first, okay? 3, 5, 6, 7, 10, 12. 3, 5, 6, 3, 5, 6, 7, 10, 12. Right, so we're going to sort it first, and then we're going to start pulling people out. Right, so I say, okay, my first grade, I'm going to pull out one person when G is 1, so this person will get removed. So then this will be the length of the array, I guess. Well, this is, so we'll call n equals length of grades, just to keep track of the number of people that there are. And then here we'll put n, and we'll do n minus equal G, right? So we'll subtract out one person. That'll be this first group of 3, right? And then since we've already sorted it, we can be confident that each subsequent group, if it's longer, it'll have greater elements, right? Because if I'm smaller than you, or we could be the same, right? If it's sorted, but you have more people than me, you'll always be greater than me, right? Okay. So then so now G is 2. So then we subtract 2 from the system. Now N is 3. Now N is 3 and we subtract 3 more from the system. Now N is 0. This condition is failing, and then we return the number of groups that we were able to create. All right, so that's pretty much the code, right? And that's big O of N log N time. This is what I did is I took the system, I sorted it, right? And then I started pulling people out, doing this little game of like moving people, right? Okay, so that's interesting, right? But one weird thing about this, right, is, well, what's strange is I don't really need to know the people that end up in the group. I just need to know the number of groups that I can create, right? So this code would still work if I deleted this, right? Because when we looked at this situation here, right, with the X's, right, I didn't need to know what values they corresponded to. I just needed to know that I could create that situation. And I can always create that situation, right? I can always sort the array and find the array that paints it this way, right? I can always sort the array and say that the 1 goes here, the 1 and the 2 go here, the 2 and the 2 and the 2 and the 15 go here. But I don't need to actually know what those values are, right? These values could all just be X's in my mind because I know that I could sort it and make it work, right? Basically what I'm saying is I can always make this situation work, right? I would paint it out this way, and then I would just sort and then place the elements in the corresponding spot. But I don't need to know what those elements are. So if I know it's going to work when I sort it, but I don't need to know what the elements are, then why sort it? Right? I don't need to sort it. I can leave it like this. Right? I can leave it in this situation and just say, you know, this is already what it needs to be. I mean, how else can I say it, right? Like, I don't need to sort it because all I'm doing is I'm just looking, like, even when you look at the code, you'll notice that this sorting thing doesn't do anything, right? We know it has to be sorted in order to make it work, to decide who goes where, but we know we can make it work without deciding who goes where, right? I know I can make the situation work for 10, 6, 12, 7, 3, 5. I know there's going to be a situation where, you know, I have 10, 6. I'll leave it like it is just to prove a point, right? There's going to be groups of like this, right? But they're not going to be these elements. Actually, it's going to end up being someone else over here and someone else in these positions. But doing this operation, independent of what these X's are, will work. So I don't need to sort it to figure out who they are. I just need to know how many groups I can make. So since I'm not determining the people in which groups they go, and I'm only determining the number of groups I need, I don't need to sort it. That's my spiel on that. So I don't need to do this. So this goes away. So then this becomes O of N time. All right, so we just dropped the log N. There's no sorting involved now because we've figured out that it doesn't really matter how many sorted. We just need to figure out the number of groups that we can make. Okay? Now, one other thing that we're doing here, right? One last optimization, which is strictly a mathematical kind of idea. Okay? And this will get us down to the perfect runtime. What we're really doing is we're figuring out, you know, we're taking our N value, we're taking our length of grades, and what are we doing in order to get an answer, right? We're trying to figure out if I can subtract, how many times can I subtract out of it, right? Like this, the length of grades is 6. So I could subtract out a 3, then a 2, then a 1, and my answer is 3. All right, this is where the problem's going to get real crazy, okay, guys? So just bear with me. Right, this O of N thing is already sufficient enough, but if you really want to blow the socks off your interviewer, right, if you really want to impress them, there's an idea here which is essential, okay? And that is, well, what is this really doing here? What this is doing is I'm pulling out a g until g is less than 0, right? So I'm trying to find a case where I subtract out 1, and I subtract out 2, and I subtract out all the way up into this g value such that it's greater than or equal to 0, right? I'm trying to find that g value. These are not pluses, these are minuses. All right, that's what this code essentially here is doing, right? I'm starting with g equals 1, and I'm subtracting it from the length of grades. Then I make g 2, then 3, until n is less than 0, right? Until grades is less than or equal to 0. All right, so that's equivalent to saying I'm going to move some stuff around, do some algebra here. I always get confused when I do it like this. So grades, the length of grades is greater than or equal to 1 plus 2 plus g. Now I'm going to put it the other way just so it's easier for me to think about it. I like having stuff on the left. This is just a personal preference. Less than or equal to grades. Again, I didn't flip the sign. I just like turned everything around, right? Because it's supposed to be 1 plus 2 plus g is less than or equal to grades. Okay, so 1 plus 2 plus blah, blah, blah plus g is less than or equal to grades. Okay. Now this is 1 plus 2 plus 3 all the way up to grades. Okay, so that's the sum from I equals 1 to g of I needs to be less than or equal to grades. Now, I'm trying to find what this g value is. Now, this is a special sum, and it has a closed form solution. Okay? The sum from 1 to g, and all the numbers in between, is just g times g plus 1 over 2. This is an established formula for this situation here, is less than or equal to grades. Okay, now I'm trying to find out what g is. I'm trying to solve for g. So say g times g plus 1 is less than or equal to 2 times the length of grades. All right. So then I'm going to do g times, I'm going to do g squared plus g minus 2 times the length of grades. See, guys, math can get complicated. Even simple math can get complicated when you're dealing with all these variables. Is less than or equal to 0. All right, now how do we solve this? Because we're trying to find what g is, right? We're trying to find the value for g. And all I'm literally doing is I'm taking this code and writing it out in a mathematical way and saying, okay, is there a closed form way I can do this? Instead of calculating this sum, can I capture it in a formula? Okay, so to solve for this, do you guys remember the quadratic formula? So negative b plus or minus the square root of b squared minus 4ac all over 2a. Does that sound familiar? Right? This stuff does come back every once in a while. Now, what is our b and our a here? So these are the constants. So our a here is 1. Our b here is 1. And our c here is negative 2. It's negative 2. B is 1. A is 1. Okay? So let's plug that into this formula here. So we got negative 1 plus or minus the square root of b squared is 1 minus 4. A is 1. C is negative 2. All over 2 times a, which is 1. All right, so that equals negative 1 plus or minus the square root of 1 minus 4 times 1. So that'd be 1 plus 8. Make sure I did this right. It's been a while since I've been doing simple math like this. All right, so that equals negative 1 plus or minus the square root of 9 over 2a. Oh, 2a, 2 is 1. Why did I do that? 2. All right. So that equals negative 1 plus or minus 3 over 2. Oh, wait. I messed up. C, I was wondering, I was like, why does this seem so perfect? It's too perfect. Things like this are never that perfect. So C equals 2 times grades. Right, because we're trying to solve for G here. So anything that's not G is a constant. So this is 4AC times the length of grades. Right, so this means that this equals -1 plus or minus the square root of 1 minus plus 8 times the length of grades all over 2. All right, so our G answer, right, the number of groups we can create, is -1 plus this. Or -1 minus this. All right, so how's there two solutions? Well, there's not. And I don't really know because it's, what is this, a palabra? Man, it's been a long time since I've taken pre-calculus. Calculus, whatever. But the idea here, right, is that, what's the idea here? The idea is this like, logically to me, this one doesn't make sense because grades is positive, so then this would be positive. It'd be 1 plus that, so it'd be greater than 1. So then you'd have a negative value. In G, you can't have negative numbers of groups, right? So the only one that makes sense is this one here. So basically what I'm saying here is you can take this and turn that into a solution. And I'm being completely honest, right? This is the number of groups that you can create. Right? The number of groups you can create is -1 plus all this divided by 2. I'm literally just throwing the formula in that we just calculated. I'm going to do floor divide, right? Because you could have, like this situation, there's only 1, even though there's 2, because you have to have whole number increments. Right? If I have one group, I can't have like a 1.3 group. It has to be a whole group. So these would have to go in one group. So this floor divide will handle that situation where you don't have a perfect number of groups to sum. And so -1 plus or minus plus the square root. So to do the square root, you can do this. This needs to go inside of here. My bad. So this would be a square root, 1/2. 1 plus 8 times the length of grades. All right. 1 plus 8 times the length of grades. And we'll just return that. So I did a floor divide, yet it's still... I did floor divide, though. Floor divide should force it into... Okay, I don't know. I thought floor divide would make that happen, but I guess not. So we'll just convert to an int. All right. Do that. You don't need to. Right, because any remainder, right, if you had 7.3, for example, right, if you had like... The reason why this int thing works, right, is if you have like 7.3 or something, right, you could make 7.3 groups. Well, you can't make a 0.3 group, right? It has to be a whole number. So if you just int this, right, you'll get 7. That's kind of the idea behind that. All right. So I just did a lot of crazy stuff. Math is fun sometimes, right? There's some crazy stuff you can do with mathematics. I've seen stuff done with mathematics that would blow your mind. This is like, a lot of people would say this is probably pretty, you know, not a lot of people, but, you know, some of those pretentious folks would say that this is nothing, but it isn't nothing. It's pretty cool, right? So that's kind of the basic idea, right? We can take, you know, this situation, right? And we can take, well, okay, we can look at the number of groups we can split it into. We can always make that work by sorting it. Oh, well, it turns out you don't actually need to sort it, so you can just find the number of groups. Oh, well, it actually turns out that this can be converted into a closed form solution, which is this code here. All right, guys. Beautiful math problem today. Hope you have a beautiful rest of your day. Bye-bye. Wait. Runtime. Runtime. All right, so I'm actually a little bit confused on this. I've always been a bit confused. All right, so you might say that this is a constant operation. See, that's why I get so confused by this. Okay, someone in the comments help me. If anybody's still watching this, please in the comments describe to me this because I'm still confused about this. Okay, so n is the length of grades, right? For space, it's obviously 0. I mean, it's obviously constant, right? Because we're not even creating any variables. We're just returning. But for time, you might say, okay, this is a constant operation, right? Like I'm literally just taking this, doing a calculation. It's constant. Well, if n is the length. Well, that would mean log n then. If n is the length of grades, then yeah, it's constant. Okay. So it's constant. It's one operation based on the thing. You do one calculation, you're good. Sorry, guys. Have a beautiful rest of your day. Later.